In Chapter 10, we're going to learn about an important data structure and a useful data structure in Python called lists. Lists are really easy to build. You just put whatever you want in your list in a comma-separated list of objects, and then you enclose it using brackets. A list can be made up of any kind of object you want. So in this first case, I have a bunch of strings. In the second case, I have a bunch of integers. I could make those floats if I wanted. And in this case, I actually have a mixed list with some strings and an integer on the end. You actually have a list of any kind of data structure or Python object that you want. So you can have a list of lists. So list 4 is going to be a list of list 1 and list 2, at least initially. And then we can print off a list, just print list. Lists can be indexed, so I can ask what is the first element, or index 0 in list 1, should give us an A. I can ask what is the second element, or index 1 in list 2. The 0 index in list 4 should give us the entire list 1. And then you can do sub-indexing. So this is going to give the 0 index in list 4 will give us list 1. That is another list which we can index, and index 2, 0, 1, 2 should give us a C when we print that out. Lists are mutable, unlike strings we saw before. So I can reassign list 4 index 1 to be a different list. So I'll make it the list of integers 2, 3, 4, and then we'll print off list 4 to check to see that in fact list 4 was changed by doing this. And then we're going to print off list 2. List 2 was the list here in this index. And so we might question if we make these changes to list 4, have we affected list 2 at all? So let's check. I'm going to run. Okay, so we print list 1. And then we print the first index in list 1, which is an A. The first index, the second element of list 2. And we print off list 4, which actually is just list 1 again. And as we said before, sub-index into list 1. And the second index, that gives us a C right here. We can print off, well, we made a change then to list 4. And we printed list 4, and we can see that there's a new list in the second slot. And then we made that change to the second slot in list 4, which says up here list 2, but in fact, when we make the change to list 4, it doesn't affect list 2 at all. This is a copy of list 2. So we don't make any changes to list 2 when we make this change to this part of list 4. Okay, so now some other interesting things that you can do with lists. Lists are iterable. So I'm making up a new list of famous mathematicians, the top 4 mathematicians on most people's list. Newton, Gauss, Archimedes, and Euler, not Euler, it's Euler. And we can print this list off. And then the neat thing that we can do with any list is we can do a for loop that takes us through that list. So we're going to say for mathematician. This can be any variable you want here. Since they're mathematicians, I chose to call that variable mathematician. So for mathematician in A, and that is going to take us through this list one by one in the order that you put them in. And we will print mathematician, and then we're going to print mathematician plus law. So we'll have Newton's law, Gauss's law, Archimedes' law, and Euler's law. And then we're going to print off the list again, just to check that we haven't done anything in here. And then you can make changes to the list if you want to. Again, lists are mutable. I'm going to do a for loop through the list in a slightly different way. The length of the list is given by length len A, And so we're going to set up a range. So this will go from 0 up to the length of a minus 1, which is perfect. So 0, 1, 2, 3. And for each one of those indexes, we're going to take the string, which is at that index, so that is a string, and we're going to add to that another string, apostrophe S's law. I forgot the S. And then we're going to reprint our list. So let's see, list our iterable, and we'll run that. So here's the original list, and then we're printing mathematician and mathematician's law. And so you can see how this goes through that list, that for loop. So this is a really nice, elegant way to write for loops in Python. Python for loops are really great. We then print the list again, and then we actually make changes to the list in the second for loop, and we add apostrophe S's law to each one of those names, and we reprint that list, and this is what we get. So a couple of good techniques in here for modifying lists or working with lists. A simple for loop to take you through a list, and if you need to modify a list, here's a neat trick to do that. We're going to learn something more about strings. This can be very useful when you're doing work with files, and we're going to see more examples of this in the next video, or an example of this, I should say, not more examples. But for right now, you can take a string. So I've made up a string here, Fred, Wilma, Barney, Betty, and take that string and split it into a list. So this is a string, and that string has a method. This is called a method when you put a dot on the end of it. And that method is called split. And if I don't put anything in here, it's going to split the string based on any white space characters, so blanks. And if there's any carriage return line feeds in here, it would split on those too. I'm going to run this right now so we can see what split does. We're printing out the string, and then we're going to print out L1 here, which is that split. String split method. And so what it does is it takes that string and breaks it up into a bunch of smaller strings, taking out the space separators, and makes it into a list. And that turns out they can be very useful, as I said. So we'll see how that works, or how it's useful in the second video from this chapter. You can split on other objects. In this case, I had a comma separated list, and I split it on a comma. So you can have an optional parameter here on what you want to split on. And you can see that that gives us the exact same result. And then I made up a third list with last names, so Wilma Flintstone, Fred Flintstone, and Pebbles Flintstone, and split it on space, comma, Flintstone. And get one little, so you could use this maybe to remove last names if you had a string of last names or a string, who knows. But you get this last little empty string here, and here's the thing. When you split on an object like this, or a string, or whatever, it's expecting that there's going to be more information after this last space Flintstone. So I split it on space Flintstone to remove the space after Wilma and after Fred and after Pebbles. But it's expecting more data at the end of this last separator, and it didn't find any, so it just said, hey, there's an empty string there. That would be easily compensated for if you wanted to do this split. This is just more an example of, there are lots of different ways to do splits. But it does give you a list, and again, then you could, if you needed to, iterate over that list, for example. The string, Fred, Wilma, Barney, Betty, you can't iterate over that, but if you split it, then you can do a for loop over those names. In fact, we could just do that now. So we have L1, we could do a for loop for name in L1, and then we'll just print name. And that is not something that you could do, with that string. So there we go, Fred, Wilma, Barney, Betty. And last thing, we're going to learn some methods that you can use on strings. There's operations that you can do to strings. Made a new list. In this case, I'm separating first name and last name. So we have Wilma, Fred, Barney, and Betty. We're going to print out that list. There's the length operator, which we've already seen. And just kind of a reminder that L here is a nested list. And then if you look at L0, that is a list. It's this list right here. It's got two things in it, Wilma and Flintstone. And so as a list, we can ask for the length of L0. Okay, so our first method that we can apply to lists, you can append things. So we're going to append Pebbles and Bam Bam. So we're going to put the kids on the end of the list, and then we'll print that out again. So append just simply puts things on the end of the list. And again, this could be anything. I've kept the formatting of first name, last name, but you could append anything you wanted to the list. Insert works a little differently. So this is going to insert at position 2. So 0, 1, 2. It should put this right here, Dino. So we're going to add in the dog. And then we're going to remove the dog. So we have a way to remove Dino. And it's just remove just an object from the list. So whatever that object is, you can remove it. You don't have to use an index like insert where you use an index to put it into the list. And then there are some conditionals that you can use with lists. So we can check to see, is Dino Flintstone in the list? And after we removed it, it shouldn't be. So this should turn out to be false. And we'll ask, is Wilma Flintstone in the list? And she will still be in the list. So we should get a true here. And then we can ask, where is Barney Rubble in the list? So let's run list methods and see what we get as an output. So here's the original list, and it has length 4. So there are 4 things in here, Wilma, Fred, Barney, and Betty. And then the list with Wilma's name in it, which is L0, has length 2. And then we've appended 2 more pieces of information to that list. So now the list has length 6. Then we stick Dino in at position 2. 0, 1, 2. Then we take Dino out. So we remove Dino, and then we're here in the code. When we do that, that's this list right here. Then we ask, is Dino in the list? Is Dino in L? And no, we just removed it. But Wilma is, so that's true. And then we can say, where is Barney Rubble in the list? Barney Rubble is at 0, 1, position 2. And I commented this out because when I run this, it's going to give us a little bit of a problem. We can ask the index for Dino. Dino's not in the list, and so it's going to give us a hard time about that and say, hey, there's an error here. This is not in the list. You can, if you want to read a little more, we'll get into this later, trap that error and catch it. Or we could just, before we try to print this index, we could check, is Dino in the list? And then if Dino's in the list, we could say, oh, well, then what's his index? Okay, so it might be better to say if here if Dino's in L, print like that. And we're not going to get anything else. Or we could just add else. Something like that. So, sorry, Dino, you're not in the list. All right, lists. There's an introduction. The next video we're going to. So these are all really the sorts of things we expect you to be able to do with lists. In the next video, we're going to actually show how to use lists to solve some problems that might come up.